Good morning everyone, we are from Group 2. Today we are going to talk about metacognitive and metacognition. First of all, what is cognition? Cognition is the mental action or process of acquiring knowledge and understanding through thoughts, experience, and the sense. In simpler words, it means thinking. Metacognition is thinking about our thinking. It's generally defined as how people or individuals monitor and control their cognitive processes. It was introduced as a concept by John Flavel. Flavel said that metacognition is the knowledge you have of your own cognitive processes. It refers to higher order thinking, which involves active awareness and control over cognitive processes engaged in learning. Metacognition is considered a critical component of successful learning because it involves self-reflection and self-regulation of strength, weakness, and type of strategies you create. There are basically two main theory frameworks in the field of metacognition research. One is done by Brown and another is by Flavel. Brown emphasized on knowledge and regulation of cognition. Flavel emphasized on person, task, and strategy variables as a subcomponent in metacognitive knowledge. Recently, researchers suggested that metacognition should include three components, which is metacognition knowledge, metacognitive experience, and metacognitive skills. The first component in metacognition is metacognitive knowledge, which consists of personal, task, and strategy variables. Personal variable refers to self-knowledge. For example, knowledge on one's strengths and weaknesses. Task variable, on the other hand, refers to knowledge of the range, demands, and condition of tasks as well as factors that influence the task. Strategy variable refers to the knowledge about cognitive strategies, pedagogy, and tactics used to handle various situations. The second component of metacognition is metacognitive experiences. It refers to the feeling, judgment, and online task-specific experience, which include both cognitive and affective feelings. For example, the sense of achievement when complete the task successfully. The last component is metacognitive skills. It refers to the activities and the use of strategies for the effort and time allocation for the task. It involves the step of planning, monitoring, regulating cognitive processing, evaluating the outcomes, and have self-reflection.
Metacognitive awareness. It is the ability to reflect on our own thinking, develop and use practical problem-solving skills to resolve learning difficulties. It means here, being aware of how you think and being aware of how you learn. Developing metacognitive awareness is an important part of helping learners become more effective. It enables teachers or students to be more mindful of what they are doing and why and how the skills they are know or learning might be used differently in different situations. Metacognitive awareness allows teachers to reflect on their work, prompting them to evaluate their instructional goals, methods, and outcomes. For example, teachers may ask themselves the following question after teaching this one lesson. What actually they want to achieve in today's lesson? Did the explanation can be understood by students? And how teachers can improve the instructions follow students' need? Also, through the lifelong skill of metacognitive thinking, students can be taught to reflect on their own learning processes while they complete the learning tasks. Metacognition enables students to reflect on who they are, what they know, what they want to know, and how they can get to that point. Benefits of metacognitive awareness. Through this metacognitive awareness, students are able to self-assess their needs in learning and self-assess the area of potential weaknesses and identify their strengths. And the students' metacognition also help teachers understand student learning. It is where the educator learn about themselves as teachers when they promote metacognitive awareness among the students, because the reflective thinking allows students to offer valuable feedback to their teacher regarding whether teacher explanation were effective or confusing. Therefore, the awareness of how students learn enables teachers to be better focus the instruction and make better use of the class time.
Strategies to develop metacognition can be embedded in traditional learning activities. There are several methods to do that. The first method is think aloud technique. Teachers can demystify the reading process by explaining the behind-the-scene thinking that is required for good comprehension. The second method is reciprocal teaching activities, where teachers provide steps for exploring the text, encourages students to think about their comprehension strategies. The goal is for the students to work independently through the steps of questioning, clarifying, summarizing, and predicting. The third method is self-assessment done by students. Continuous student self-assessment encourages independent learning and prompts students to be more aware of their progress. Tools that can be used are checklists, reading logs, and skills inventory. The fourth method is questioning. Questioning is indeed a powerful cognitive strategy because it prompts students to focus their learning by searching for the information they want to know, helping them to focus and organize their thinking. The last method is problem-solving activities. Teachers should use these activities to promote active engagement with the content, which requires students to shift the facts into analysis and application of the content, so that students can know what they have known and what they do not know.
Next is challenges in metacognition. The first challenges is metacognitive attitude and ability of students and teachers in science stream class, especially chemistry. For students, metacognitive attitude explores student assumption based on their learning experience. Meanwhile, for teacher, metacognitive attitude explores teacher perception based on the teaching experience. But for metacognitive ability, it is explored by the test result of the mathematical and also science content question. So both student and teacher knowledge on declarative, procedural, and also conditional will be assessed. Therefore, in order to evaluate the metacognitive knowledge level of student and teacher, the Metacognitive Awareness Inventory (MAI) and Metacognitive Awareness Inventory for Teacher (MAIT) should be done. Second is literacy competence of student. In understanding the problem, students need literacy competence. The absence of the competence will lead students to fail in understanding the problem. Therefore, several techniques to improve literacy competence while improving metacognitive attitudes can be done, which is using integrated right to learn (IWTR), and then using SQ3R, survey, question, read, recite, and review, and also using PQ4R for preview, question, read, reflect, recite, and review. The third challenges is lack of assessment, reflection, and a deeper analysis of the students' metacognitive skills, motivation, and attitude towards the course during the teaching. Task value will be promoted whenever the teacher provides a reason for the task, emphasizes the usefulness and importance of the task, emphasizes the enjoyment that can be gained from the task, and also offer choices within the task. In order to improve the students' metacognitive skills and make them use more diverse metacognitive skills, students were asked the usefulness and importance of the course and whether they enjoy the experiments they perform in the reflective forms given before, during, and at the end of the course. Next is lack of skills to design metacognitive instructional practice. Teaching with metacognitive strategies means that teacher will think about how their question will activate and develop students' metacognition. Therefore, instructional strategies that will develop metacognitive skills such as Socratic questioning, inquiry-based learning, problem-based learning, cooperative learning, project-based learning, and also context-based learning can be imposed during the teaching. And the last challenges is limitation of teacher cognition of engaging learner in scientific practice. Understanding aspect of teacher cognition related to scientific practice is important in light of recent education reforms. There are many types of knowledge teachers need to acquire to successfully engage their students in scientific practice in the classroom, such as subject matter knowledge, scientific practice knowledge, nature of science knowledge, and also pedagogical knowledge. Therefore, reflection and continuous improvement of the teacher can span a range of thinking process. A teacher who thinks about and reflects on her teaching can take a metacognitive stance by being aware of the complexities of the classroom and her role as a teacher. It is likely to achieve a higher ability to translate inquiry or scientific practice into the classroom. As a conclusion, educators recognize that integrating learning and thinking strategies into daily classroom activities on a long-term basis brings good results, helping students gain a better understanding of how successful learning takes place. Teaching students to monitor their cognitive processes by developing strategies for thinking, comprehending, and remembering is a valuable investment for their future. Through metacognitive instruction, students can practice these skills over time, increasing the chance that these valuable thinking strategies will strengthen their practical intelligence and become part of their repertoire as learners.